Hello, 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 and welcome to LaserBeam Live. This is show number 10. We made it this far. We made it into the new year. Let's start this off with a happy new year to everybody watching. Thank you for joining me this evening, afternoon, morning, wherever it is where you are. I'm very glad that you guys joined me today. Today, I feel like I say this almost every other week, but today's going to be a quick stream because I only have one goal in mind, and it's to set us up for a project for the next stream. So let's start off by taking a look at the chat. Koala was super early as he always is. What's up? Uh, Bucky, how you doing? Jack, Bill, Juan, how you doing? Doug, people have a voice. Yes, they do. What's up? Arthur, how are you guys doing? Can you guys hear me? Are we good? Is the quality good? Are we good? We're not lagging. You guys can hear me. We're not in a wind tunnel. Joffrey. I'm sorry if I mispronounced your name. Thank you for joining us for the first time. Awesome, awesome, awesome. Joffrey, this is going to be a stream about the Rotary, so you might not get into too much of the simple stuff. So if you're new here, definitely check out the past live streams. You can start with number one. I think the first couple live streams we went through a lot of the basics as we started to progress and start to engrave and cut different materials and projects and stuff like that. So if you're new here and you're a little bit confused, this is going to be a quick stream, but you can after this stream you can always check out the other ones. They're all saved on the CNC Labs YouTube channel, so you can go back and watch. Start with the first one, and then you can go through it, and hopefully you learn a little bit. Yeah, there's a bit of an aura around me. Volume's a little bit. Yeah, the mic does it like if I move the mic a little bit closer to me, it's a lot easier. Uh, but I got the shirt right. Let's just cover the letters so it spells aura. My sister gave this shirt to me. She works for the company. That's not a plug. Yeah. Okay. I'll try to keep it like this. I'll try to, maybe I can angle the headphones a little bit more. Um, I can also jump up the volume, but when we start running the laser driver, it'll also pick up the laser driver. And I think last time it was a lot more echoing. So I'm just gonna try to speak a little bit louder for you guys, so you guys can hear me. And when I'm not operating anything, I'll try to keep the mic a little bit closer. But I'm glad you guys are doing well. I see Jack got a very, very, very expensive new laser machine, our fiber laser master, Jack. Very cool stuff. 100 watts is a lot of power. That's a very nice machine. I'm pretty sure it's very expensive as well. So, Jack, if you ever looking to send some free gifts, you can always send them over here. That's a joke. We're all right. Damn, almost 5 grand, and that's U.S. I'm presuming. So that's probably like $50,000 Canadian. Whoa, 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 that's awesome. All right, guys. So today we are calibrating our millimeters per rotation for our rotary axis. Why do we care about this? Because in order to map things out in Lightburn, we need everything to be accurate. So last week or last 2 weeks, the holidays, hopefully you guys had a great holiday season. Hopefully you guys are all rested. Your bellies are full. But last week we were playing around with the rotary axis and we were just engraving some stuff. I've been just playing around, just trying to get the sizing right. And it seems like in order to get all the sizing right when I'm designing, we need to lock in an appropriate millimeters per rotation. So I will pull up Lightburn right now. And these are the settings that we're looking at, right? So Lightburn makes it really easy to play with the rotary axis, right? we just choose chuck or roller. Ours is a roller. We enable the rotary axis. We replaced our y-axis with the rotary, so all we do is select the y-axis, and then we only have 4 inputs, one of which is the object diameter, and that automatically calculates the circumference. So you really only need to put one input for that, and all you do is measure the diameter of your item, and boom, it'll calculate that automatically. So if you change the diameter, it's going to change the circumference. So the other measurement is the roller diameter. Super easy. Let me pull that up for you guys. So roller diameter is also super easy. All we're doing is measuring the diameter of the roller. So we input that. That's a super easy measurement. But lastly, this is what we need to um, do a little bit of light testing in order to get it pretty good. So what we're trying to find out is how many millimeters causes a full roller rotation. So based on the motor that you're using, um, the pulley system that you're using, the belt system that you're using, one rotation, that's what we're trying to do. We're trying to tell the program what is one rotation so that, because if you think about, let me try to use this, let me try to full screen this. So if we think about millimeter rotation, so if the roller is twisting and we need it to make a perfect 360, then everything becomes more calibrated. If that's not calibrated, when we flatten this out in our design program like this, if I set something to 5 millimeters across and our millimeters per rotation is off, it's not actually going to come out 5 millimeters across this arc, right? Unless that is fine tuned, right? So I could be making something and I know the circumference is 60 millimeters. If I make the length of my project on the y-axis of my design program, Lightburn, if I make that 60 millimeters and the millimeters per rotation is not correct, it might go over, it might go under. But what we wanted to get to a point is that when we pull a line or a design that's the exact circumference, the exact length of the circumference, we want one rotation to line exactly back up with the start point of the job. That's how we're going to know that our millimeters per rotation is locked in and is working correctly, so that when we design other things, we'll never have to change that because that won't change with the design. All we have to change is the diameter of our actual material, and then everything should align for any type of future designs there. So before the Christmas break, our last live stream, I put in a pretty arbitrary number of 5 millimeters for rotation because it was getting me the design on the material without overlapping and without being too large. So I was sticking with that just out of ease. But today I'm going to try to lock it in a little bit more. And the number that we need is going to be this circumference, right? So I'm going to copy that. And I'm going to use a rectangle. So I'm going to make it a very thin rectangle because it's just easier. It's just easier that way. And I want the height to be the circumference. So I'm just typing that in. So it's 69.115. So I'm putting that down here, and I'm putting it at the origin point 0 and 0. So why am I doing this? When it rotates, I need the beginning of this down here to line up right here. That's how I know my millimeters per rotation is set correctly, right? So you guys will never have to deal with this because once we have a production model, we'll be able to lock everything in here. So all you have to do is grab the number from our resources, plug it into your program, Lightburn, and you'll be all calibrated. But because we're prototyping, this is something that we need to figure out. And every time I make a new prototype, if things change, I'll need to figure this out again. So this is just a good little test. And the reason why we're doing this now is because next week or next 2 weeks, our next live stream, I want to engrave a cup. I want to engrave a glass cup. So what that's going to entail is making the design. It's going to entail painting a thin layer of black paint across the cup, and then it's going to require me using our rotary axis to engrave it. So if everything goes well, we'll be getting a nice etching into the engraving. The paint will allow the laser power to actually uh, penetrate the glass and not go right through it. And then we'll be able to wash the paint off, and then we'll have a custom engraved glass. Um, and we might even have a new prototype by then. So we might, I'll do this on the back end if this changes, but I'll recalibrate it if we end up having a new prototype. So I'm going to be trying to change the prototype a little bit because I would like to be able to have an adjustable roller width. So right now you would have to unscrew on the current prototype, plug it into the next one if you wanted to increase it. And I only built this one with 2 different sizes. So the next one you'll just be able to twist a screw and one side of the roller will move, adjusting the width. So hopefully I'll have that prototype finished for the next stream. But either way, even if I don't have that prototype finished, I will use this prototype to attempt to engrave some glass. So that's a first. It'll be our first legitimate project on the rotary axis. It'll also be our first legitimate project with any transparent material, and it'll be our first laser project on glass itself. So that should be fun. So let's kind of get right into this. So I have my line. It is the exact length of the circumference. So if I run this, it should go from beginning and it should line up exactly. It shouldn't go over, it shouldn't go under. So let me just double check my power settings. And that seems pretty good. Good enough to engrave on wood. And then I'm going to save G code. We'll save it as rotation test 1. And I will list the millimeters that we're using so we can keep track of it. Pop over to G-Sender Edge. If you haven't played with G-Sender Edge, if you haven't tried G-Sender Edge, this is where a lot of the more cutting-edge features are being implemented, and then eventually those features will merge into the main G-Sender. So if you want to kind of have availability of like the most cutting-edge features that the software team is playing with in terms of machine interfaces, go ahead on our website, go to the G-Sender page, find G-Sender Edge. You'll be able to download it in the GitHub for whatever computer you have, Linux, Windows, or Apple. I'm hoping to etch the actual glass. I'm actually hoping to etch the glass. So what the paint will do is hopefully stop the actual laser from penetrating it and actually hold that power in the actual glass so that we can actually engrave it. So it's a pretty common technique. We might have to play with the type of paints that we're using, the type of power that we're using, but my goal is to be able to actually etch the actual glass, not the paint. At the end of the project, we're going to um, wash the paint away. So whichever side you paint of the glass is the side it's going to engrave, and we don't really want small fractures on the inside of the glass because that could be dangerous. Over time, little bits of the glass will probably fall out and go into whatever you're drinking. So we're going to paint the outside of the glass because wherever the paint is, that's going to be what's stopping the power, and that's going to be the layer of the glass that it's actually going to absorb the actual power, right? So I'm going to zero all, and then I'm going to load our project. So as you can see, the sizing is a bit weird, but that's because we're using a rotary code. Um, so, guys, I'm going to try to keep the mic close to my close to me while I speak because I'm turning on the driver, and hopefully you guys can still hear me. Let me know if that becomes an issue where you can't hear me, but I'm going to try to talk a little bit closer so you can. So we have our rotary here. We have our sorry guys, I just want to make sure our camera is all good. Let's go to webcam. Oh, so I just got to update our camera. One sec. There we go. We're all good. So we have our piece right here. I'm gonna try to full screen that so you guys can check that out. So success means that the lines match up to each other. They don't go over. They don't go under. If all of our settings are perfect, then everything should line up. I already know this is not going to line up because I've already tested this millimeter per rotation size. But I just want to show you kind of what we're doing here. So I'm gonna go ahead and start the project, and then we will take a look at the results. So that was really quick. And so we have two issues here. So our first issue was that we ran it too fast. So we didn't really burn on our material enough. So I'm going to be lowering the speed. Let's go 7 millimeters per second so that we can really see it. I'm going to save the G code. I'm going to save it at the same file because that was pretty much a fail. And then let's rerun it at the new power settings. And then let's go back to the webcam and let's try it one more time. There we go. So, so you guys can hopefully see this. You can see that line starts right there and ends right about there. So Steven's asking, is there no rotate one rotation command like dialing in a full turn? So there is on Lightburn. So I'll show you guys how to do it on Lightburn. I'm doing it on GSender just because I like to use GSender. But if you guys wanted to run the code on Lightburn, then I'll just turn this off for 1 second. Guys, I'm using the G2 lens just to answer Bucky's question. Because of the limited Z height that the rotary axis provides, you will most likely be limited to the G2 lens just because of the focal length. And I'm going to try to keep the rollers as low as possible to give you guys access so you guys can use the most amount of material, the biggest diameter material. Um, but you're going to have to use the G2 lens because we want the shortest amount of Z axis loss. So when the Z axis is at its biggest point, the distance between the rollers and the focus point of the G2, which is about 30 to 35 millimeters, that's going to be how big of a diameter you can actually put into the rotary. So with the G2, that'll be very large, and hopefully you guys can complete all the projects you need to do. That's why we like the G2 because it is the overall lens. Good for engraving, and it's the best for cutting because it has the most power efficiency. So when you go to Laser Tool and Rotary Setup, you can click Test, and it should do one full rotation in one direction, one full rotation in the other direction, and then it should move back and forth. So it'll test the x-axis, and then it should do one rotation forward, one rotation back. The reason why I'm not using it is because use uh, I don't use Lightburn as a machine interface, and I kind of want to go through the design process just for anybody who's new, who does use Lightburn into GSender, because that's the workflow I use, that's the workflow we promote, that's the workflow uh, we like to show. Oh yeah, don't worry. The software engineers and the other mechanical engineers, the product designers, are also working on some in-house things for GSender. Um, and I could probably just make a macro for that. So maybe that's what I can do over the next 2 weeks, and I can play with macros. But I just did this to make it easy. So we already know um, where is our one piece. Oh, here it is. So we already know that this is not going all the way. We're pretty close. Like, we're not that far off. If you guys can see, that's the end and that's the beginning. So we're really not that far off. So for this one, I'm just going to change it to, let's do 7. So 7 millimeters per rotation. Let's save our G code. Let's save it as the same file name, but we'll just change up which millimeters per rotation we entered. So this one should be 7. Let's pop that back in. Let's turn everything back on. Let's head back to GSender. Let's open up the new job. There we go. And let's run that. All right. All right, guys. So we got it pretty close. So as you can see, we got it pretty close. That's the distance. So we're super close there to getting a full rotation. So we are almost there, guys. So I'm going to pop that back in. I'm going to go back to Lightburn, back to Laser Tools, Rotary Setup, and let's try 7.5 millimeters per rotation. Let's save the G code. Same name, but we're going to change it to 7/5. I can't. Actually, can I use? No, I can't use period, so I'll say 7-5 or 7_5 to denote the decimal there. I am going to pop this back up. Let's load up the new code. And let's run this up one more time. Oh, sorry. Let's start the job here. Let's go back to webcam. Yes, you can. Steven, that's also a good That's a good easy way to do it. The reason why I'm doing it this way is because I'm also showing any newer people just how to use the workflow of the laser. So and light burn and G sender. So that's why I'm gonna do things this way just to show like how it actually runs. Where we make something, we change the power setting, we export as a .nc, we put it into G sender, and then we run it. So this is a longer way to do it, but I think it will have more educational purposes for those who aren't as caught up with the laser. And then for those of you who are like Steven, like you're gonna find different ways to do it. There's the test setting in Lightburn if you want to use Lightburn as a if you want to use Lightburn as a machine interface, you can turn uh, laser on, and then use your y-axis, right, just like he said. Turn it off. Lightburn is a great software. Lightburn is really the best software out there. So let me just load up this new one, and let's start the job. Let's see what's happening. All right. Let's see how we did. And guys, we are so close here. We are so close here. So it's the top one right here. That is so close. We are almost. We just want it to finish on that same job there, on the same point. And then we are good. So let's change this up one. Hopefully this is going to be the last change we make. I'm looking at the difference that 0.5 made, and we have significantly less of a difference to make. So I'm tempted just to put 7.6. Save this 7.6. And I have a feeling that we're going to be pretty well lined up here. So hopefully this is the one that gets us there. Yeah, so Scott, yeah, you can keep your laser on. I always take it off, and then you can also use it offset through the settings here, spindle laser. When you're not using the laser, you just turn it off, and then when you include your X and Y offsets, every time you um, enable it, it's going to offset by that. Yeah, so I remove my laser. Dust isn't great for any electronics in terms of longevity, so I remove it just to kind of protect it a little bit. But so I'm gonna open that up. So this one should be it. We might even go over, and then we might have to reduce it even a little bit. Yeah, we're gonna work on that. I do have to, we have to kind of come together and see where that's at. All right, that looks pretty good. We only have one dot here. So as you can see, we only have one dot here, which means they pretty much lined up. So that's kind of what we want. So 7.6 ended up being, and I'm sure I could align it even more, but this is good enough for me. Let's do a quick little project. let's do a quick little project there. So now we know our maximum height, and then our width is just going to be the length of our part. So this is the part I'm going to use. So this length is 52, and then we have our circumference. Yeah, we can Stephen, if you we can try that after. I just want to get a project in, but I want to change our width to 52, and that is now that rectangle now represents our workable area. So if I type test, and then I rotate it by 90. Oh, wrong part. We want to rotate our text by 90, or in 270 actually. Let's move it around here, and then let's take up as much space as we can. So that looks pretty good. Now I don't need this rectangle anymore. Yeah, Glenn, you can purchase Lightburn from the CNC Labs website. Under the product tab, you can go to laser, and then you'll have Lightburn license there. And yes, Lightburn will continuously update as long as you have the license. So let's we can get rid of that. Yeah, so we do have a bit of a discounted Lightburn on our website. They also have a free trial, so you can try it out, make sure you can learn all about it, and then you can purchase it from us or directly from Lightburn. It is a little bit cheaper directly from us, and they do give you continual updates. They have a great forum. It's the software I use, so I'm going to be able to help you as much as I can, and yeah, those kind of the benefits of Lightburn. So I'm just starting this at the 0 point here. Yeah, there's like Laser Web. That's a free software, I believe. It's like an online software for creating G code. There's a few different softwares out there that you can do for free. Yep. So everything uses the same G sender. Lightburn has its own machine interface that you can use directly to send code, but the way I do it and the way I do it on all my streams is through GSender. So I just, it downloads as a .nc file, and then you can pop it right into GSender just like regular router code. Yeah, Lightburn is just like the best software out there for laser code, whether you're doing CO2 fiber or diode like ours. Lightburn, they just seem to have the best stuff out there. So let's turn everything back on. Let's get that situated. You can turn it back to webcam. I'm just going to fire a test just to make sure we're pretty aligned there. Yep, looks like we're good. And then let's run this test. So our laser is a true 7-watt output laser, right? So it is one of the most powerful diode lasers. Obviously, there are companies that do multiples, so you can get multi-diode lasers, but you have to be careful because there are different type of quality issues with different diodes. And after a lot of research, we kind of found the best out there. So what happened here? So what we're seeing on this project, one second, guys. What we're seeing on this project is we're getting some slipping of the belts because, as you can see, the T and the E are overlapped and the S is fine, but then now the T and the S are overlapped. So what we're seeing is as it rotates back and forth, there's some backlash and there's some the belt isn't perfectly tensioned, so we're seeing some slipping there, and that's why we're seeing the overlap. Yeah, we're getting some slippage there. So I don't think the slippage is coming from the rollers um, and the material. I think it's coming from the actual tension of the belt and the motor. So that's why this is prototype number one. It's going to have issues. I'm going to make number two, have a tensioning system and have a roller adjusting system for the width. So having an adjustable tensioner and having a adjustable roller width is what we need for the second one. So that's why we're seeing that issue right there. So before we end this stream, I do want to test to make sure that we do want to. So this isn't slipping on the roller, or this didn't slip on the roller. It slipped. The actual belt pulley system is slipping. Here, let me see if I can show you guys here. Hmm, let's go back to webcam. So guys, I'll rotate this so you guys can see. So this is essentially what's happening. I'll try to move my hand out the way. So when it's twisting and turning this way, it seems to be fine, but on the other end, we're seeming to be losing some steps. So when it's going really fast, like back and forth, the belt here is going to be slipping on either this. So I tried to add a bit of a tensioner, but as you can see, there's still a little bit of slack here, right? So if we wanted uh, to stop that slipping from happening, we would want to have like an adjustable tensioner here. So either the motor slides back and forth so that you can add that extra little bit of tension, right? Or this is adjustable so that you can kind of pull this and push it and tighten it exactly where you're going to get the most type of tension. And then you can do that over time. So this was just a like I use parts that we had in house. So I used a lot of the stuff that we had in house. So I just went to kind of our prototyping. Um, and I just threw together a bunch of stuff that we had lying around. I didn't want to use any of the new stock. I just used a bunch of old stuff um, that was available for prototyping. So I just whipped some stuff together. But now that I kind of have an idea that I can get this thing to work, now it's just about getting it to work better. I can kind of start ordering parts specifically for this and start to make things a lot higher quality, make things the way that they're supposed to be, proper tension, adjustability. Um, So my goal is to start shipping in late April. and I don't want to throw out a price right now because I don't have a proper BOM. So there's no way for me to there's no way for me to price things until we know exactly what it's going to cost to get the parts over here from our actual suppliers. So I don't think it's going to be too expensive. I think it's going to be on par with the other rotary systems. So between $100 and $200 is what I seem to be seeing from all the other companies. And you know us, we try to make the highest quality product for the least amount of money, and we try to balance that. So as highest quality for the reasonable price, that's kind of our business model. So I'm going to be trying to do the same thing with the rotary axis. They're going to be trying to do the same thing for the chuck rotary axis for the router. The router one will be a lot more expensive. So we're going to try to make the details there very specific where, if you're just using the router for laser stuff, then you might want to spend, 100 to 200 bucks on the roller rotary axis. And then if you're going to be doing router stuff, then you might want to spend, I don't even want to put a price to it, but it's going to be a lot more expensive, two, three, four times more expensive, depending on where their bomb lands them and what the labor cost is to get it one made and assembled. So I don't want to throw any numbers out there because it could change, and I don't want to be held responsible for any of your expectations. But we keep things pretty reasonable. Yeah, a lot of you guys will look at the chuck and you'll be like, "Hey, I'd rather have the chuck," and a small amount of you guys will be like, "Hey, I don't really do a lot of work. I don't really want to do a lot of rotary work with my CNC. I'm just going to get the laser router, which is why it's going to be a lot cheaper uh, for the laser than the actual router fourth axis." And we're going to try to make things as spelled out, easily spelled out for you guys, so you guys aren't buying something that you're not actually using. I don't want you to spend 100, 200 bucks on the laser rotary axis and then be like, "Hey, I actually need the more expensive chuck one." And I don't want you to buy the chuck one and then be like, "Hey, I don't actually do a lot of fourth axis router work. I wish I just bought the laser rotary because it's easier and I'll end up using it more." So we're going to try to spell that out pretty basically so you guys can make the right decision for you and buy what you need. And, no. So we're not going to, for at least for now, we're not going to play with like putting them two, trying to make like two for one because they're just so different. Yeah, they're just so different, and you lose even more of your z-axis with the chuck. So we have to deal with that, where like you might not have enough z-axis to actually laser anything on a chuck, and then you'll have enough to do it on the roller. So yeah, I'll talk to the guys. I'll talk to the product development team and see if anybody wants to um, you know, let me show off the truck one for the next job, or maybe they want to come on or hop on, and maybe they want to set up a separate stream so that they can start showing you guys. They're putting out updates as they're making stuff and as they're figuring stuff out. So yeah, these two are going to be separate. We're going to be working together so that we're not stepping on each other's toes, which is going to be very hard to do because they're just simply two different machines. They're two different add-ons at two different price points. So yeah, no, we're definitely not going to skip on the quality, but definitely going to make it reasonably priced. So we're not going to gouge you with the markups. We're going to, price it properly in the market, but also put the quality as high as possible so that even if you're paying the same price for ours than you would for another company's, you're going to be able to tell that our company's was made at the same quality or even higher. And then hopefully our support kind of gives that even more of a value add where you send us an email, you're going to get an email within a few days or same day, or you call us, you're going to get a call same day or next day. Uh, any plans for a stronger laser? Not really. Um, I think the where I want to go with upgrading the laser is start to play with CO2 designs, um, and the only way to kind of get that done is to kind of build out a whole new formatting system um, for a CO2 laser. More power. Yeah, I don't like I don't like stacking diodes. It's like diodes are very limited and they have their place. Um, but I believe like if you're really like itching for more power, I think start looking at CO2 lasers, and that's what I'm going to do eventually, as long as it kind of aligns with the company's kind of goals for the long term. That's where I want to start looking, because we use CO2 lasers in house, and we know a lot of you guys probably have like very cheap CO2 lasers in your own shop, and either they're over from overseas, so you don't have the support that we can offer, or you spent a lot of money on it, and yeah, it's a very expensive machine. So we're always trying to kind of I'm going to try to bridge that gap. But again, I'm going to work with the team and talk to the guys and make sure it kind of aligns. Yeah, so a 60 watt, a 40 to 60 watt CO2 laser is kind of where I'm thinking. Yeah, when it comes to diodes, it's a bit of a tricky market because a lot of companies lie about their diodes, and it ends up being a very tricky market because we test our diodes, we spend a lot of money on our diodes, and our support is kind of where it's at. So, uh, good night, Bucky. Thanks for joining us. Thanks for all that you do for our company. Thanks for all that you do for the community in terms of your tutorials and your projects that you post. You have a great night. And I think I'm going to end the stream right there. I think I'm going to follow Bucky's lead. And guys, I'm going to try to have a glass system or a glass project for next stream. And I'm going to try to have a better prototype with um, tensioned, tensioned belt, and a whole better system that will kind of keep things one step closer to production model, and then get us one step closer to actually releasing something you guys can use or even think about using. And yeah, so guys, thank you for joining me. This has been a short stream. This is LaserBeam Live 10 with Ikenna for CNC Labs. Check out the other tutorials. We have a bunch of router tutorials, a bunch of router videos. I know you guys have seen we have upped our quality on all of our tutorials and all of our marketing and our video quality and our projects. And we just released an ebook, a compilation of projects that we have videos for. So guys, support. You guys are the best supporters. You guys are the best customers that a company could have. You guys always support what we do. You know that we're never trying to kind of throw new products or new add-ons on you. We just release what you guys tell us to make, and you guys seem to love it. So we're going to continue to do that. I'm going to see you in 2 weeks. We're going to try to etch some glass. I'm not going to promise success, but I'm going to promise that we're going to try, and we're going to see what's happening. So guys, if you have any more questions, you guys can send in tickets with the word laser. If you have issues with your laser, if you got a laser and something's missing, if there's something wrong with your driver or your laser and you're under warranty, send us a message. If you're not, we can send you orders for replacement parts. Guys, I'm here to support the laser in all ways. Um, yeah, come down to the office. We are open, so come down and check us out if you guys are in the area. Scott, I'm going to talk to the product development team on the truck and see if they want to either join my live stream or if they want to book their separate live stream. But I'll let them know that I have a lot of interested parties, even in my chat, that want to see what the truck can do live and kind of want to play it with it and ask questions. It would be cool to do a joint time. Maybe it's not. Maybe it doesn't take over the LaserBeam live, but maybe we set up a separate live stream where me and them can kind of jump into it and ask a lot of questions, because I know a lot of you guys were going to be curious. So yeah, I'll talk to them. We'll set something up for you guys. You guys have an amazing evening. You guys enjoy the rest of your week, the rest of your weekend. Um, yeah, guys, I'll catch you on the next one. Bye.